Okay, we've derived the Laplace transforms of the sine and cosine functions. Let's apply them to this differential equation. Now this is a familiar type of equation. You can verify that the homogeneous equation would represent an oscillatory system with omega equals 2, so that the solutions to the homogeneous equation would be combinations of cosine and sine of 2t. We're forcing this with the function cosine of 3t. For simplicity, we're going to start at equilibrium and velocity 0. If we Laplace transform this equation, and I'm not going to write out the intermediate steps, just going to write out the Laplace transform of y double prime, which is s squared times the Laplace transform of y, minus s y of 0 minus y prime of 0. Of course, those are both 0. And then it's going to be plus 4 times the Laplace transform of y equals the Laplace transform of the cosine of 3t, and that's just s over omega is 3, cosine of omega t, omega is 3, so that's a cosine, that's s squared plus 9. These terms being 0, we get s squared plus 4 times the Laplace transform of y equals s over s squared plus 9. Laplace transform of y is therefore equal to s over s squared plus 4 times s squared plus 9. Now, how do we inverse the Laplace transform? Well, we first break this into partial fractions, then we use common sense. We're going to get something over s squared plus 4 and something over s squared plus 9, which is going to lead us, fairly obviously, to something like, well, our denominator is going to be of the form omega squared plus s squared. Here omega would be 2, here omega would be 3, and that fits nicely, of course, with what we already know, what I already said. The homogeneous system has a combination of sines and cosines of 2t, and the forcing function is a cosine of 3t. That just matches very nicely with these denominators. So let's work out the partial fractions and see how that goes. The partial fraction decomposition would be as plus b over s squared plus 4 plus cs plus d over s squared plus 9. And I'm going to write the details off camera, and we'll come back in a second. Okay, the details are very straightforward. Hopefully I wrote them down correctly. Just multiplying numerator and denominator here by s squared plus 9. Our numerator comes out as plus b times s squared plus 9, and multiplying numerator and denominator here by s squared plus 4, we get cs plus d times s squared plus 4. The denominator is just the product of these two factors, as it was, as it is. Okay, multiplying these out, our coefficient of, we have as times s squared, which is going to give us an s cubed. Cs times s squared is also going to give us an s cubed. That's going to give us a plus c times s cubed. Now we're also going to get s squared terms. We get one multiplying by b. We get another over here multiplying by d. So we get an s squared term. We get s terms. We have an a here that gets multiplied by 9, and a d here, a cs here that gets multiplied by 4. So we have 9a plus 4c times s. And then we just have 9b plus 4d. And not sure how I managed to write 9a plus 4b here, but it should be 9b plus 4d. And that's going to equal 1 over this denominator, meaning that The coefficient of s cubed has to be 0. Coefficient of s squared has to be 0. It's going to tell us that a and c are equal and opposite, b and d are equal and opposite. Then it gets a little more complicated because 9a plus 4c is the coefficient of s, and I said that equals 1 over this. It's s, not 1. Okay, the numerator here is s. So that the 9a plus 4c is going to equal 1. I wrote the 1 because I was kind of focusing on it. It is 1s. Now that 1's going to start looking like a 7 or a 2. Okay, and then we have 9b plus 4d, which is a constant term. There's no constant over here. That's going to be 0. So we're going to write down the 4 equations and their solutions, and then we're going to see just what this is equal to as two fractions, one with the denominator s squared plus 4. This is going to give us a sine or a cosine of 2t, and an s squared plus 9 denominator. It's going to give us a sine or a cosine of 3t. Okay, these systems, the system of equations that we get, and I've just written it down. It should be obvious how it follows from this. This is 0, this is 0, this is 1, this is 0. We get a equals negative c, b equals negative d from these two equations. Then replacing a with negative c, we get negative 9c plus 4c equals 1, which gives us negative 5c equals 1. C is negative 1/5. And b is negative d, so we get negative 9d plus 4d equals 0. And that tells us simply that d equals 0. Plugging that back into this form here. Off camera, we'll come back in a second. Okay, our original assumption was that Laplace transform of y, which is s over this denominator, breaks into this pair of fractions. Solving for the coefficients, or the parameters a, b, c, and d, we obtain these results, so that the Laplace transform of our solution function is going to be as plus b over s squared plus 4 plus cs plus d over s squared plus 9. A is equal to negative c, c is negative 1/5, so a is 1/5. We have 1/5 s over s squared plus 4. B is 0 because b is equal to negative d, and d is 0. C is negative 1/5, d is 0, so this term becomes negative 1/5 s over s squared plus 9. Then factoring out the 1/5, negative 1/5, we get this. So what does y equal? Well, it's 1/5 of whatever has Laplace transform s over s squared plus 4. Okay, what has Laplace transform s over s squared plus 4? It's going to be s over s squared plus omega squared with omega equal to 2. And that's going to be the cosine of 2t. Then we're going to have minus 1/5 here. And that's going to be cosine of 3t. Now this solution does satisfy the initial conditions. Okay, y of 0, well, cosines are both going to give us 1, so we have 1/5 minus 1/5 gives us 0. Y prime of 0, both of these cosines are going to give us sines, and the sine is going to be 0 when t equals 0. So the initial conditions are satisfied. Do these solutions satisfy the original equation? Okay, I've written this out. These are sines. I started to write cosines, so let's put a big dot over the I so we can tell that those are sines. That's what I just said, and I'm just going to say this. A cosine of 2t will give you second derivative negative 4 cosine of 2t, and that's clearly going to give you 0 on the left-hand side. And if you got the 1/5, it's going to be common to both terms. So this is a solution to the homogeneous equation, in other words. 1/5, negative 1/5 cosine of 3t is a solution to the non-homogeneous equation. If we take two derivatives, we get 9/5 cosine of 3t. And then if we subtract 4 times this, we get negative 4/5. 9/5 minus 4/5 is 5/5, which is 1. So this checks out. And if you don't see that in your head, write it down. But this checks. Now your text is going to go into a little more detail. It's going to be a little more formal. But you have the flavor of the situation. And you should have no trouble reading the text, filling in the details, doing the problems. Naturally, you submit the problems, and I'll give you feedback.